Greetings. Today I'm going to talk briefly about how Hammerspace technology is being used to expand and accelerate production workflows at a respected visual effects customer. As you may already know, Hammerspace is a software-defined data orchestration and storage solution that creates a global data environment across otherwise incompatible storage types, geographic locations, as well as hybrid environments that may include one or more cloud providers and cloud regions. It unifies file access and file granular data orchestration via a high-performance parallel global file system that spans all of these storage types and locations. In this way, Hammerspace enables cross-platform data services to be automatically applied non-disruptively to users and applications across all of them. These services include metadata-driven workflow automation, tiering, migration, and other data placement tasks, plus powerful data protection services that can be managed globally across all storage types. In addition, as an open system, Hammerspace is easily extended for third-party application integration to enable other solutions to take advantage of this global reach across data silos and locations. Today we will describe one such integration that is being used at Jellyfish Pictures. Hammerspace enabled Jellyfish to not only cut costs by seamlessly extending their on-prem resources to cloud, but also to grow their business and rapidly expand their operations globally. Jellyfish initially adopted Hammerspace to reduce their cloud rendering costs. Render jobs that needed additional cloud resources were limited to their local Azure region. The problem is, because of their location, Azure compute resources in the London region are much more expensive than if the render could move to other regions where power and cooling are cheaper. With Hammerspace's ability to seamlessly bridge multiple cloud regions, Jellyfish is now able to route render jobs dynamically to whichever cloud region is cheapest. From a user's perspective, the workflow has never changed. Hammerspace is integrated with Autodesk Shotgrid, enabling users to schedule render jobs to Azure as they always had. But because the Hammerspace global file system can span multiple Azure regions simultaneously, render jobs can automatically be routed in the background to the cloud region where costs are lowest. This enabled Jellyfish to save as much as $300,000 on a single render job just because of the lower compute costs available in other regions, and with no change to user experience. To grow the company, however, Jellyfish needed to be able to take on more film projects. The problem was finding additional talent near to their London studios. To solve this, Jellyfish stood up Hammerspace instances in Azure POPs in Australia, India, and South Africa, effectively extending their London production environment so new teams in these locations could immediately begin working with the same user experience their London artists enjoy. Without the need to stand up new infrastructure at these locations or to shuffle data copies around the world, the remote teams were online and able to access the global data environment with no delay. Finally, Hammerspace enabled Jellyfish to tie a second Toronto-based data center into the global data environment. Now all users across all locations are able to see all of their data across all of their storage resources, including on-prem and cloud-based resources. In this way, Hammerspace has enabled Jellyfish to not only cut costs, but also to win new business with rapid provisioning and expansion. For the next few minutes, Hammerspace Solutions Architect Michael Bott will walk you through a condensed demo. It will show two views, one as though from a user at headquarters, and another as a remote user accessing the system via Azure. Both are accessing the same files in a global file system. And then he'll show you how they trigger a job with Shotgrid.
So you can see on the left side, again, I have the site HQ. On the right side, I have the site Azure. You can see on both of these UIs, they have a view of the global file system, between two sites. There is the local site and the remote site. So we can see local here and then Azure on the remote site. It's reversed on the other side. I do want to talk about the building blocks, though. So the first thing I can talk about is on the infrastructure side, and I'll show you that on both. So at the top level side, I have two locally attached disks, and then I also have the Azure blob. And then I grouped those local storage volumes into something called local storage. And what that did is it automatically created an objective that I can leverage called place-ons. And then I have something called a smart objective. So I have this waiting fin keep local, and then I have IP keep local. So I'm going to switch to the ShotGrid thing in a minute. You might chuckle if you've ever seen the basic demo ShotGrid setup, because those are the projects that I'm using for this demo. But they have 3 statuses defined. There's WTG, waiting to start. There is finished, and there's IP, in progress. And we're going to show you custom metadata being applied by a ShotGrid events plugin, and setting that, and then these objectives are the things that are going to make the data local. So let me show you what this looks like. So there is a wizard that has a nice graphical approach to creating an objective, but we also have a language, effectively, that lets you describe the behavior of data. And this is a very simple thing. Hopefully it whets your appetite or gets your imagination rolling to how you could leverage this in your own workflows. So you can see here, if get tag, so I'm using a kind of metadata that we call tags. If get tag, so SG status list is the name of the tag. Okay, you might recognize that from ShotGrid. Equals IP, then service level objective, that's what slow means, place on local storage. Okay, so again, that local storage is what's attached to the DSX. And if I go back over here to infrastructure and data, and I go to projects, if I just mouse over the applied objectives, you can see my IP keep local objective there. So I've applied it to the share. Usually that's best done automation, not interactively, because it can get kind of complicated. But you can apply this on a file granular level. In this case, I just want to apply it to the whole project share. Now, what I'm going to do is descend into projects on both of these sides. Let's get into an actual project. So we're going to get into this animation project here. So I'd probably have directories the way you probably have them named, after sequences and shots and so forth. Okay, so I want to point something out here. So this data is all in headquarters right now. Okay, you can see the remote column. It all says no. Whereas on the right side, the remote column, now the directories are not remote. Directories are just metadata, right? So those are everywhere. But you can see the actual data, remote is yes. I mean, and in fact, we can descend into the pictures directory with a bunch of stuff. And you'll see all of these are remote, including my Max DS store. So let's watch what happens here when we go to ShotGrid. So I'm just going to go into pictures here. Remember, you've got remote no and remote yes in Azure. And I've got a fake workflow here wherein when I flip something to in progress, I want to move it to Azure. That's what the objective says. So let's do that real quick. You can see over here, let's get into the animation folder. Again, the right side, drive Z is Azure, drive H is headquarters. And one thing you'll notice in my Explorer view is that these look like regular files. That's pretty typical. These actually show that they're offline files. Okay, so there is some sort of signal to the user that there is not a local instance of that data. But that said, I can actually browse, no problem, right? I can do whatever I want in the data over here. It feels nice and snappy. It feels interactive to that user. And let's say I want to just go ahead and open a piece of data that's remote. Okay, this is what I'm going to do first before I fire off the ShotGrid one. So I'm going to open this Apple, and we're going to create some rad visual effects on it. You can see that just opened, right? It was not a local copy of the file. It did take a moment. You saw the application pause, but here it is. Here's our Apple. And let me go ahead and let's make some cool visual effects on it. Okay, there we go. And then we're going to close it and save it. All right. And now what's happening in the background is that the Azure Anvil is letting the headquarters Anvil know that there is a change to that file. I could come in here, I can open that file, and you'll see it pause again because we're pulling down changes. There's my awesome visual effects. Okay. Now, that's cool for on demand, but a lot of times you might have big files or a lot of assets that need to be worked on in the remote site. And you don't want those guys waiting while they're opening all of those dependencies for a scene they're working on or something like that. So let's see what happens here. You could have a human come in and say, okay, in this animation project, I want a particular sequence. Okay. And in this case, any sequence will cause a data move. So I'm just going to show you this. We can change the status of a particular sequence. Okay. I'm going to change it to in progress. Remember, in progress is what gets it moved to Azure. So we say in progress, and then over here, you're actually going to see the status change here. You saw it just pop up. You can see the information about the event. And there's a lot of data in this that I can use to create a directory that corresponds to that sequence or shot that I just changed the status of. But you can see down here, we switch from waiting to start to in progress. And let me show you on the Hammerspace UI what's going on right here. It's already aligned. I guess it got ahead of me. This was pretty quick. Now, instead of remote, most of this data now, instead of saying yes, it now says yes cached. Okay, meaning there is a locally cached instance of that data in the Azure site. And so now, when I go to the Azure site, let me do a refresh on this. And you'll actually see the offline files indicator go away, right? So now I can open this. Let's open it again. We're going to our awesome VFX application here. I'm opening a new file. This is a different apple picture. I've got lots of apples because I'm at the top of the alphabet. Let's draw some stuff on here. So, we've got artists doing work now in the cloud. Okay, maybe they're remote artists. They're coming in using Teradici or whatever your favorite high performance remote desktop technology is. And now I've got those files modified. And if I come back over to show you what they look like on the Hammerspace side, you can actually see now, although lots of other things are remote, now these things that I edited are starting to show cached. So you can see the system rapidly becomes aware of the remote changes that happen. So consider where you can go with this. Okay, you can drive behavior like in my animation project within one shot, I've got different assets that are going to be worked on in different locations. And you can select for that in these objectives. You aren't just confined to tag. You can select from any piece of metadata you want, file extension, file path, any of the timestamps, ownership, permissions, all of those things are available to be operated on as objectives. You can even say things that have seen 100 IOPS in the last 48 hours. So you have a lot of ability to determine where data gets placed, and it buys you an almost immediate efficiency increase once you can start doing this on your expensive core storage, where you've got 2 petabytes, where a lot of that stuff hasn't been touched in months. You can do things in Hammerspace like move that data to a cheaper, slower volume.